And next we have Dr. Zachary Pirtle, and as Jerry and several others alluded to, he'll be talking with us about the commercial lunar payload services. Dr. Pirtle is a NASA program executive and engineer in the Exploration Science Strategy and Integration Office. Dr. Pirtle.
Thank you, Lisa and Kevin. Very excited to be here to talk today about commercial lunar payload services, also known as CLPS. And yes, we're excited to be a part where we're helping to do a lot of the demonstrations that STMD was just talking about. We're helping to deploy the Viper rover that Tony Colopate will talk about. Just a little bit about where we are inside of NASA. So I work at NASA headquarters as a civil servant within the Science Mission Directorate. And the Exploration Science Strategy Integration Office, SEO, is the part of SMD that most focuses on integration between human spaceflight, space technology, and our science schools. So we often work very closely with Kevin and the overall BPS program in order to think about how we can use CLPS in order to do exciting science from the moon and excellent science from the moon. And I'm one of the program executives in the office that tracks and mines the CLPS task orders that I'll talk about here in a bit. So with that introduction, next slide, please. So commercial lunar payload services, CLPS. So we are an innovative service-based competitive acquisition approach. And our goal is to enable affordable and frequent access to the lunar surface by a growing market of American commercial providers. We formally, in terms of how we do our procurements, we are an IDIQ indefinite duration, indefinite quantity contract that goes to 14 contractors that I'll talk about in a bit. Our task orders are all firm fixed price. And so one of the things that does when we're working with other mission directorates is that we try to make sure that we have the scope of future prospective payloads that are nailed down. So we work really closely. So for BPS, if people on this call are thinking about developing instruments towards CLPS, I'm going to have some guidance and information in this talk that would help you to understand the process of how something gets manifested on CLPS, and then how to design and think about being affordably accommodatable. Now, CLPS is interesting in that NASA is not trying to be the only customer for the CLPS missions. We're trying to work so that our CLPS partners are able to get commercial and private sector deliveries that can go on the CLPS missions. Some of our vendors have publicly declared that they have non-NASA payloads on their flights, which is very exciting for us in terms of creating a broader lunar economy. So when there is a CLPS mission, though, we contract with them for the delivery. We're sort of akin to FedEx in that sense, that we're working on making sure that we do the agreement for what the payload is going to be, and then if they have extra room in the trunk of the FedEx car, then they're able to bring more material over. So the specific NASA missions, when there is a delivery, they are run and led by the provider. They are not done by NASA. So they are, in that sense, they're CLPS provider missions. They are not NASA missions in the traditional sense. So NASA does not own the hardware. We have less insight into exactly what is going on with the development of the system, although we have ways to get more insight, especially for higher value payloads. So regulation in order to ensure safety and mission assurance for a CLPS launch is done by the FAA because they are commercial launches and activities. Next slide, please. So when NASA solicits payloads for CLPS, they are owned. If it's a NASA-developed payload, then it's NASA-owned. If it's an international partner payload, then it's owned by the international partner. It's not owned by the CLPS providers. So they have custody, and they lead the landing of the payload to the surface of the moon. They work to do the safe integration. So if there's a future biological and physical sciences payload that goes on board, they're responsible for integrating it. They try to accommodate, they are contracted. They must accommodate the payload interfaces, operations, and environment requirements that are specified by the payload. So they procure the hardware. They will, if necessary, make deals to get DSN support. This is not supervised by NASA's Launch Service Program, as it's, in that sense, it's truly commercial. So there's different things that you can do with CLPS. So it's not necessarily the most common thing that people look to CLPS for is for the physical operation of a payload. So to get it down to the surface, to operate it, to provide power, and to allow communications to come back to Earth. There can also be payload deployment into cislunar orbit. And there can be other things that are simply placed on the surface as passive objects. So we're deploying a number of laser retroflectors. There can be education and public outreach items. And we do have ways to, as needed for high value payloads, to contract for augmented insight that gives us a deeper understanding in what's going on with the developer's activities. Next slide, please. So we currently, I'll talk about the CLPS vendor pool. We do plan to expand the CLPS vendor pool at appropriate moments to allow new capabilities to on-ramp. And while we've been increasing the magnitude of the payload deliveries that we've been deploying on CLPS, we're expanding and hope to have increased options for the future. So these options could include the ability to survive and operate through the lunar night. And the time frame for that is very indefinite and will be determined based upon the capabilities of the vendors. We have been looking at having increased delivery and mass volume. We're looking at having mobility services where you can have a scientific payload that if you desire to have a specific scientific instrument to be able to explore and see different parts of the lunar surface, we can compete it so that the CLPS vendors need to be able to provide that service, and the vendor that is best able to meet those requirements, given the different evaluation criteria, is likely to achieve it. We are capable eventually to do some sort of sample return delivery through the CLPS service, but again, that's contingent upon the capability of the providers. And there could be options for operation in permanently shadow regions and other places. So it's we're starting out and we're excited to have our first two deliveries next year. And based on how CLPS task orders develop, we'll see how the capability on-ramps from there. Next slide, please. So these are the 14 CLPS providers. So one thing that is important if you're thinking about using CLPS is that NASA will compete, once the payload is selected, it will compete across all the 14 CLPS providers to see who can best accommodate the requirements of an individual payload and an overall CLPS manifest. So if you see one company on here that perhaps you as an instrument developer have had some connections with, there's no guarantee that if you go through CLPS that it will be manifested on that particular company. It will be based upon the competitive outcome of which of these 14 companies proposes to best accommodate these options. So it's very exciting. You've got a mix of older heritage aerospace companies, as well as newer, small businesses that are all together. I'll talk in a bit about the 4 companies that have existing task orders through CLPS that we're moving fast in order to get payloads on the surface. Next slide, please. So these are our currently awarded task orders. So as I was just saying, the competition, every request for task order proposal goes through this vendor pool. The 6 missions that are currently in work for deliveries are listed at the bottom. The first 2 are the task order 2 deliveries. There's task order 2 Astrobotic, which is set to have its Peregrine lander land in 2022. And the Intuitive Machines task order 2, which is also set to land in 2022. Now, the dates here need to be updated based upon recent schedule changes. There's also deliveries through Maston, Intuitive Machines, and then Astrobotic is set to deliver through task order 20A, the Viper rover in late 2023. The most recent task order that was awarded is by Firefly Aerospace, was the winner, and they're set to land with their Blue Ghost. I mentioned before that we've had an emerging portfolio of the CLPS vendors that have on-ramps. So we did have an initial set of CLPS vendors that you see shown in the top right there. After the first on-ramp, the vendors that you see shown there joined into the pool. And if we have future on-ramps to the CLPS pool, then there could be more vendors that are part of the competition to deliver task orders. Next slide, please. So the process, if you've got a payload, how to get it formally manifested through NASA's Commercial Lunar Payload Services. I should note that it is possible that if a private group has their own funding, they could contract directly with these lunar delivery companies in order to do a delivery. So this is about going through NASA's process to get delivered and manifested on CLPS. So we do work carefully through the CLPS Manifest Selection Board for NASA-launched payloads on CLPS. And we have representatives from the Human Exploration Operations Mission Directorate, the Space Technology Mission Directorate, the International Office at NASA, and of course ourselves within the Science Mission Directorate. And we work carefully as SMD develops a lot of its payloads that I believe Kevin Sato has talked about earlier. There are opportunities through PRISM and other aspects to have BPS payloads be selected for CLPS. So there's a process for selection that it is this prism. That's what's shown in the bottom right value there. A lot of this is NASA inside baseball in terms of how the different mission directors work together to do a payload. But for biological and physical sciences payloads, the BPS division within the Science Mission Directorate at NASA will use a process to solicit payloads, as Kevin Satos talked about. I'll go to the next slide. Once there's someone inside of NASA who's based either on a competition such as the PRISM process that I just mentioned, or if international partners are collaborating and have talked to NASA and there's a NASA stakeholder that's developing it, we go through a process in order to get the payloads manifested on an Eclipse flight. And I'll just say that once that first step is that a partner identifies, or someone within NASA identifies the need for Eclipse delivery, there's a pre-manifesting review to try to understand just how complex are the interfaces of the payload. Does it have unique mission needs that might drive up costs for the overall Eclipse delivery? We work towards eventual finalization of what the manifest would be. And then we release something called an RFTP, a request for task order proposal. That's where we send out the competition to our vendor pool and ask them to work on the delivery. So that's about all that's needed for this audience here. Next slide, Kevin. This is a little bit more on the process of it. So for those who do get selected through a process like PRISM, in order to fly on CLPS, there's this process would be explained to you by NASA headquarters. But the main thing to take away is that there's a cascading process of trying to mature what the interfaces for the payload are. So once identified, you need to work with the CLPS office in order to identify what your payload requirements interface development is. Once it's been manifested on a request for task order proposal, RFTP, there's workshops with all the CLPS vendors to be able to ask questions of the payloads to understand what the requirements are. And there's a final competition that's released that allows the CLPS vendors to propose, and then NASA evaluates and picks a winning task order, such as the ones that I talked about earlier. So this is a bit of an eye chart, but the main takeaway is that throughout this process, the goal, because it's a firm fixed price contract, is to get to more mature interfaces as time goes on. Next slide, please. Once a payload is manifested, NASA provides additional support through a payload integration manager. There's a project scientist that looks across all the payloads that are on a particular mission and works to optimize the operational goals and procedures across the different payloads to make sure that NASA is getting the best science return from those activities. Next slide, please. So again, I want to emphasize here that payloads, they set the requirements. The CLPS providers need to accommodate those requirements. They need to accommodate those interface complexities. But if there's something that's unusual interfaces, such as currently something that operates during the night due to the cold temperatures is difficult to do and might drive costs, there are reflections that we want to provide cutting edge support for new science instruments and for technology payloads, but we want to make sure that they are we're properly balancing things across our manifest. So we do need these stable interfaces, as I was talking about before, and the CLPS task orders are awarded competitively. Next slide, please. Now, this concept of affordable accommodation, while we accommodate your unique driving requirements, we've been sharing an increased level of discussion about what are common interfaces that exist across the CLPS vendors that people can look to try to design their payload. So again, if you've got a unique driving requirement that enables your unique science return, we want to support that, but to the extent possible that there's a way to align with what the majority of the CLPS vendor pool can do, we think they can help to drive down costs and make sure that there's a strong competition across the vendors. So in sum, on the affordable accommodation, it's to try to be as normal to the extent possible. Like we often use 28 volts of power. If you're designing something that's a rover that needs to deploy from the vehicle, try to be flexible in terms of the way in which the rover can deploy from the vehicle. There's a number of things that I could talk about in more detail if people have questions later. But next slide, please. For those who are selected to fly as Eclipse payload, there is a need to support payload workshops that go over the details, that talk about their requirements, that allow the CLPS vendors to ask questions that can help them make sure that they give a competitive and technically sufficient proposal that will be able to to meet the needs across all the payloads that are on a flight, because there's typically multiple payloads on every CLPS flight. Next slide, please. This reiterates what I was saying before, that for a typical CLPS payload, there's an increasing level of fidelity beginning once the payload's been selected and the vendor's been chosen. There's a lot of work that goes on between the CLPS vendor and the instruments to increasingly define what the payload interface is, what are the operational requirements. Everything needs to align to the requirements that are put into the initial request for task order proposal, RFTP, but there's details that are always captured as designs mature and move on that can't be 100% detailed out in advance in the RFTP. So we try to make sure that the requirements at the initial stage of the process bound whatever things they're done later in the project, but we realize that there's a lot of maturity that has to go on in any given project. So once payloads begin to become integrated, there's a need for additional analysis by the payload that they need to plan to support as part of their activity. Eventually, the payload is turned over to the CLPS provider for launch and integration onto the lander. And then there's launch operations that leads to delivery onto the lunar surface. Next slide, please. So and this is detailed more in NASA's calls such as PRISM, where we're soliciting payloads, but there are needs for the payload deliverables to provide information to the CLPS providers. So it's not just you sign the contract and it's done. There's an ongoing discussion and dialogue between payload deliverables, payloads, and the CLPS vendors along the lines of what we're talking about here. So there could be do no harm requirements applied towards the payload. There needs to be some sort of integration support and then on-site support, and along with the other things that you see here. Next slide, please. So I'll wrap up here. I talked here about CLPS today, but as I mentioned, there's the PRISM call for soliciting instruments, and so that's a separate SMD procurement activity, and Kevin Sato, I believe, has provided information to the group about how BPS will be using PRISM or other sources for potential CLPS missions. I think there's a lot of complexities towards CLPS. We're excited about moving forward, and we hope to have a lot of deliveries next year and to keep enabling both science goals on the moon and then also technology development needs. I'll end my talk there, and I'm happy to answer any questions if there's time.
Great, thank you very much, Dr. Pirtle. I believe there will be many people wanting to take advantage of the CLPS program. So I think we have time for one question. Is the CLPS program requiring payload testing and qualification in a relevant lunar environment?
So there can be things such as environmental TVAC tests that might be needed or required by the CLPS vendors. These would be standard part of payload accommodation on any flight. So there might be things that are needed on the ground prior towards integration onto the CLPS lander. There's been a little bit of variation in terms of what the CLPS vendors have been requiring. If they want to do an integrated environmental test at the lander level that would include the payloads on board, or if they skip that. We typically lean towards protecting for the need to do that integrated environmental test. The process on PRISM to do the overall payload selection process, there's a lot more nuances and details in that about how they decide what's a sufficiently robust design to move forward with. And I'm not prepared to speak about that at length today. So there's a lot of nuances about how to pick things, but I don't think there's a hard rule about needing to have flight heritage or having to be at a certain TRL level in order to fly, although increased design heritage and maturity is always a benefit when you're looking into a proposal. I hope that answers the question sufficiently.
Yeah, that was great. Thank you very much. And we appreciate your time and talk